Okay, start recording. It's perfect. Okay, and now I'm gonna share the board. Okay, website. Okay, share. Oops. Okay. I'm sorry, I have to sign in, I guess. Okay. Okay. Okay, perfect. So now we can start, I guess. So this is section 1.8. All right, so it's about inverse functions. Okay, so inverse functions. So probably I'm gonna start with definition of inverse function. So here's the definition. You know, like if you have a number, let's say, 8 or 7, then you'd have like a reciprocal, right? Like a 7, the reciprocal of 7 would be 1/7 or 1/8, etc., right? So for numbers, like we have a reciprocal. For functions, we have this notion of inverse function. Okay, so it's similar to the reciprocal, but it's not the reciprocal. Okay, but anyway, so let me just start with the definition. So the inverse of a function f of x. So the inverse of a function f of x well, the inverse of a function is a function. So is the function, let's call this function the function g of x. So g of x, okay, says that. So here's the condition or the definition of the inverse function. So we need f composed with g. So f composed with g of x to be equal to g composed with f of x to be equal to x, just x by itself. All right. So so this is the definition of the inverse. So this function g is the inverse of the function f. So if f composed with g is equal to g composed with f is equal to x, just x by itself. All right. And actually, I mean, we denote this inverse of f. So we denote this inverse by, so we denote the inverse g of x of f of x, the inverse of f of x by, so this g of x is f to the power, so to the power -1. So f power -1. Right, so f power -1. And so this is just a notation for the inverse. So the inverse is denoted by this f to the power -1. And as I said, so just be careful. So the inverse, it's not like there's reciprocal. It's not 1/f. Okay, so just be careful here. Thank you, Samira. Yeah, so this, just be careful. So the inverse is not, in general, it's not the inverse, it's not the reciprocal. So the inverse of f of x is not, it's not 1/f of x. Okay, it's not 1/f of x. It's not just it's not the reciprocal. Okay, so it's not 1/f of x. All right, so well, let's have an example. Here. So an example. Okay, so let's say I have this f of x equal to 4x minus 7, right? And g of x equals to x plus 7 over 4. All right, so I have these two functions, f and g. All right, and so I'm gonna check if f or g is the inverse of f. Okay, so let's check if g of x is the inverse of f of x. All right. So how do we check if g is the inverse of f? Well, you see, so again, we have to use the definition. So definition says in order for g to be the inverse of f, you need f composed with g. So you see here, you need this f composed with g to be equal to x, all right? And you need g composed with f to be also equal to x, right? So there are two things to check. So there are two steps, so there are two steps. So first step, we need to check. So step one, we have to find f composed with g of x. All right, so let's compute f composed with g of x. So f composed with g of x would be f of g of x, right? So let me just write it down for you here. F of x is supposed to be 4x minus 7. So we need to substitute this x, so this one here, by g, right? This x here by g of x. So it's gonna be like a 4 times g of x, so times g of x, and then there is minus 7, and then there is minus 7, right? Okay, so let's do it. This is so f. So this is f composed with g of x. So it's gonna be 4 times, and then g is x plus 7 over 4, right? That's my g, and then there's minus 7. All right. First we have this whole number 4 times this fraction x plus 7 over 4. So my advice is to make this 4 look like a fraction, so just divide by 1. So 4 over 1 is 4, right? So now it's a fraction, and you can multiply like straight across here, right? So that would be f composed with g. So it's 4 times x plus 7, and in the denominator we have 1 times 4, so it's 4, and then there's the minus 7. All right. Now, because here we have multiplication, there is a 4 in the top and a 4 in the bottom, so we can cancel out the 4. So this 4 here cancel out. So it's gonna be just x plus 7, and of course in the bottom we are left with it's 1, right? This is like 4 times 1. So it's x plus 7 over 1, so it's x plus 7. So f composed with g of x, it's x plus 7, and then there is minus 7. So then plus 7 minus 7, so 7 cancel out. So you see we get, so f composed with g of x is equal to x, just x by itself. Okay, and that's exactly what we want, right? Again, definition, you need this f composed with g to be equal to exactly x, right? And that's what we have here, right? It's f composed with g of x is equal to x. Okay, so that's for the first step. So that's f composed with g. Now the second part of the definition. So you see here, first we have f composed with g, and then we have to check that g composed with f of x is equal to x. So now we in the step 2. So in the first step, guys, if you don't get x, you know, if you get something different from X here, then you can just, then you are done actually, because if it's not X, then your G is not the inverse of F. But we got X, so then we can move to the step number 2. So now in the step number 2, so we have to check, we have to find now G composed with F of X, right? So my G is, so G composed with F of X. So again, this is G of F of X. So my G of X is, you know, it's X plus 7 over 4. This is X plus 7 over 4. So there's an X in here. All right, so here we're gonna have, so this is equal to, so my X, we substitute X by F, right? And my F is 4X minus 7, right? My F, here's my F again. My F is, you know, 4X minus 7, right? So here we're gonna have 4X minus 7. So here's 4X minus 7, and that is plus 7, right? This is plus 7 here, so plus 7, and then the whole thing divided by 4. All right, so then minus 7 plus 7, so 7 cancel out here. So it's now it's 4X over 4. So my G composed with F is 4X over 4. The 4 cancel out. So here, this 4 here cancel out. So it's going to be just X. So I got, again, X, right? And that's the X.
Professor,
exactly. Yes.
I think you're moving too fast.
Too fast?
Yeah.
Sorry. Okay. And this is step 2.
Professor, are we gonna do another example with if there is no X as the answer?
Yeah. Sure. Yeah. We're gonna do another example. Yeah, sure. Yeah.
Okay.
Yeah. So. Yeah, but anyway, in this example, so all I'm saying is if you do F composed with G and G composed with F, in both cases we get X, just X by itself, right? And that means that the G is the inverse of F. So here, conclusion is that this G of X. So this G of X is the inverse of F of X. Okay. So this G of X is F to the power, -1, right? So which is the X plus 7 over 4. That's my G, which is the inverse of F. Yeah, so yeah, I went very fast with this example because, I mean, this is because, I mean, we did a lot of examples with this composition, right? But anyway, the idea is, you have these 2 steps, and in both steps, when you compose F with G or G with F, you're supposed to get X. And if in one of the steps you don't get X, okay, then your G is not the inverse. Okay, so let me do now another example. So this is an example where G is the inverse of F, right? And you see in both cases I got X. So let me do another example where
Hey,
G
Professor,
is,
so
yes.
for the homework or the exam, that will be our final answer, that we will have to put that same conclusion?
Yes. Yeah,
right.
absolutely. Yeah, right. Yeah. So you need to do this 2 steps here. This is step 1, step 2, where you check that F composed with G, and then G composed with F is equal to X, and then yes, the final answer would be this conclusion here. Yeah. So let me do another example where G is not the inverse. So this is example 1. Sorry, I'm gonna just put 1 here. So example 1. Okay, so now let's do another example. So example number 2. All right, so let's say f of x is, let's say 4x plus 3, all right? And g of x, it's x minus, let's say minus 4, or x minus 3 instead of 4. So let's say minus 3 over 2. Okay, the whole thing over 2. All right, so I have these two functions, f and g, and I want to check if g is the inverse. So I'm going to determine whether g is the inverse of f. Okay, so determine whether g is the inverse, g of x is the inverse of f of x, right? So whenever you have such a question, again, you have to check the definition, right? And the definition is this, definition is this g composed with f composed with g, this one here. F composed with g is equal to g composed with f is equal to x, right? So the first step is always, so you need to find, or you need to compute in the first step, f composed with g. So in this first step, step 1, so you need to find f composed with g, right? So if this f composed with g is not x, then g is not the inverse, right? If it's x, if it's equal to x, just x by itself, then you can move to the step number 2. Okay, so let's compute this f composed with g, right? So this is f composed with g of x, which is, again, by definition, it's f of g of x, right? So, so I want to compute this. Well, first I need my f. My f is, I'm going to write it down here. F of x is 4x plus 3, right? So what you need to do, guys, again, is to substitute this x in here, this x. So substitute x by g of x, right? So it's going to be like 4 times x. So x becomes g of x. So it's 4 times g of x. All right. And then there is a plus 3. And then there's this plus 3 here. Okay. Well, okay. So let's continue then. You have f composed with the g of x. So it's 4 times, so g of x. G of x is x minus 2 over, x minus 3. It's x minus 3 over 2, right? That's my, you see here, that's my g of x. And then don't forget there's this plus 3 here. There's a plus 3, right? There's this plus 3 here, right? So don't forget the plus 3. Okay, now let's simplify this thing here. So as I said, first you have this 4 times this fraction. Just divide the 4 by 1. So this 4 here, it's 4 over 1. And so you can, you can multiply the fractions. So how do we multiply fractions? You just multiply, straight across here, here. So it's f composed with g of x. So it's 4. So you multiply the top, the numerators, the top. So it's 4 times x minus 3. And in the denominator, we have 1 times 2, so it's just 2, right? Plus, then there's plus 3. All right. Now, well, here you can reduce, I mean, 4 over 2. You see this 4 here over 2, then this is 2, right? 4 over 2 is 2. So it's going to be 2 times, so this f composed with g of x. So it's going to be 2 times x minus 3 plus 3. All right. Again, because 4 over 2, or 4 over 2 is 2, right? So now I can distribute. So this is f composed with g. So 2 times x, it's 2x. Then there is minus. So here's my minus. And then there's 2 times 3, right? So it's 2 times 3, that will be 6. So it's minus 6. And then there's plus 3, right? So now you have minus 6. So this f composed with g of x, it's 2x. So minus 6 plus 3. So you see here, this is minus 6 plus 3 here. That will be minus 3. So that will be minus 3 here. Okay. So you see, guys, here I am done with the simplification, right? So there's nothing else we can do here, all right? And it's not, this is not exactly x, right? This is 2x minus 3. So this is not equal, this is not equal to x. Okay.
Sir,
Yes.
and when you mean x, do you mean x should stand alone? If you get like 3x and 3x, is it the same? But you're supposed to get only x as a value.
No, just x as
Oh,
a value. Yeah, just x by itself, just x. Only, yeah, just x.
So if you find any number that's not x, you're not gonna do step 2.
No, you don't. Yeah, you don't do the step 2. So actually, yeah, here we are done because it's not equal to x. Then this g is not the inverse of f. So yeah, that's a good point. So now I can actually. So we are done. So conclusion. So this is the final answer. So the conclusion is that this g is not the inverse of f. So g of x it's not the inverse of f of x. And again, guys, you need to get just x by itself, right? Not a number or anything else, just x. Okay. Any other question, guys? Does this make sense to you? Okay. So I mean, if in this, let's say in this step 1, you got x, right? And then you do the step 2, which is, g composed with f. So you will start with g first and then f. And let's say in the step 2, you don't get x. Okay, so if you don't get x in the step 2, then that means that your g is not the inverse, right? So if in the step 1 or in the step 2 you don't get x, then you're done. Your g is not the inverse of f. Okay. So well, so if there's no question, then let me give you a similar problem. So where you have to determine whether g is the inverse of f. Okay. So here's an exercise. Again, guys, it's whenever you want to check if the function is the inverse of another function, you have to do these 2 steps. And if in one of the steps you don't get x, then your g is not the inverse. Okay, so here's an exercise. Determine if whether g is the inverse of f. And yeah, whether g of x is whether G is the inverse of F. Okay. So first, let's say f of x is 5x minus 9, and g of x is x plus 5, the whole thing over 9. Number 2, let's say f of x is the third root of x minus 4. Okay, so the x minus 4 is under the third root. And then g of x is, let's say, x cubed plus 4, right? Then 3. So let's say your f of x is 4 over x plus 9, right? And then g of x is 4 over x minus, let's say, 7. Okay, so minus 7. So yeah, so please guys, determine whether G is the inverse of F. Again, all you have to do, you have to follow, you have 2 steps, right? First, you need to find, so let me just remind you here, the idea is you need to check or compute. So in step 1, so you have to compute, F composed with G of X. And in step 2, you have to compute G composed with F of X. All right. And again, if in one of the steps, the step 1 or the step 2, you don't get X by itself, then G is not the inverse, right? So I'm going to give you about 5-10 minutes to think about this exercise. Yeah, just to remind you guys, the third root means like power 1/3. So this is like, it's like power 1/3, right? Um, yes, you're correct, Samira. Yes. Yeah, number one is not the inverse. Yes, correct. So let me know if you have any question, guys. I'm here. Can you cancel out the 9? Nope. No, you cannot, Glenn. Yes, correct, Samira. It's it's in the inverse. G is gonna be the inverse. Yeah, absolutely. For number 2, yes. Kwame, yes, actually 3. Yeah, not inverse. Yeah, absolutely correct, guys. Yeah, very good. Yeah, very good. Actually, number 3 is not. It's not really obvious. I mean, just be careful. When you manipulate fractions, division fractions. It's not, sometimes it's not obvious. So just be careful with the fractions. So in later, I mean, in a minute, we're gonna see how to find the inverse of a function, right? So this is how we check. So if you have 2 functions, so this is how you check if a function is the inverse of another one. But we're gonna see there how to find, I mean, in general, how to find the inverse of a function. Do you need more time, guys? Well, I guess I can start with number 1. Okay, so let me start with number 1 then. Okay, so for number 1, so step 1, so we're gonna evaluate f of g of x. So here's my f. So here's my f of f composed with g of x. So f composed with g of x, which is again, it's f of g of x. All right, so here's my f of x. My f of x is 5x minus 9. And so I'm gonna substitute this x in here, this one here, by g of x. So it's gonna be like 5 g of x, and then minus 9. All right, so that will be f composed with the g of x. So it's 5 times, and then my g is x plus 5 over 9 minus 9, right? This is minus 9 here, so it's minus 9 here, right? So, okay. So here it's 5 times the x plus 5 over 9. So let's just make it like a fraction here. So 5 over 1. So it's like, 5 times. So that'll be equal to, so that'll be equal to f. So f composed with g of x. So it's 5 times this x plus 5 over 9 minus 9, right? So here, careful guys, you cannot cancel out this 5 or 9, right? This is 5 over 9, so it doesn't cancel out, right? So it's, this is 5 over 9, right? So it doesn't cancel out. So it's, so this is equal to, so my f composed with g of x. So it's 5 times x plus 5 times 5 is 25 over the whole thing over 9, and then there's this minus 9 here. All right, so now I'm going to split the fraction into sum of two fractions. So this is f composed with g of x. So it's 5x over 9. And then there's plus, because there's a plus in here, right? And then there's 25 over 9, the same denominator. Okay, so I split the fraction. And then there's minus 9, right? Now there's this 25 over 9 minus 9. So you have a fraction. So again, it's a good idea to use fractions here. So I'm gonna divide my 9 by 1. So this is subtraction of two fractions. So we need to get the common denominator. And if you want to get the common denominator, so then you have to cross multiply. So this is like here times 9. This is times 9. And here it's like times 1. And here it's like times 1. Right? So that's, so that's f, sorry. So that's f composed with the g of x. So it's 5x over 9 plus, plus 25 over 9 minus 9 times 9, that's 81, over 1 times 9, it's 9, right? So now I have a common denominator, so I can subtract, and so, 25 minus 81, so my f of g of x, so it's going to be 5x over 9, and 25 minus 81, that would be, let's see, 55, and so it's minus 56, right? So this is 56 over 9. Okay, 25 minus 81, it's 56. Okay, and okay, so 56 over 9. So so there's nothing else we can do here, guys. I mean, we cannot really reduce this 5 over 9, all right? So we are done. And obviously this is not equal to x, right? This is not equal to x. Right? So if it's not equal to x, then you don't have to move to the next step. You can just, so we can conclude here, we are done here. So F conclusion, G is not the inverse. So is not the inverse of F. It's not the inverse of F of X. Right? So it's not the inverse. So any question about this example, guys? Just be careful. I mean, when you subtract fractions, you know, when you reduce your fraction, yeah. Okay, so I guess there's no question. So we can move probably to the next, the number 2. So number 2, we have powers like power, we have cube, and we have the third root. So let's see how it works. So this is number 2. So for number 2, again, here's my step 1. And the same thing, I'm gonna compute f composed with g of x. So it's f of g of x. So I'm gonna write down first f of x. So my f of x is the third root of, you know, x minus 4. So under the square root, I have this x minus 4, right? Okay, so now you want to compute f of g of x. So you need to substitute, so this x here, you see this one here, x. So we need to replace or substitute this x by g of x. So we're going to have like third root. So we're going to have like third root and then square root here. And then my x is going to be my g of x. So this is my g of x and then minus 4. And then this is minus 4. All right, so okay, so let's do it. This is f composed with g of x, so it's the third root. So what's g of x? G of x is x cubed plus 4. So g of x is x cubed plus 4. That's my g of x, right? And then there is minus 4. Again, everything is under the third root, right? So now, okay, so we have this plus 4 minus 4, cancel out. So this is, oh, sorry. So this is plus 4 minus 4, cancel out. So now it's just the third root of x cubed, third root of x cubed, right? And third root of x cubed, so then, you know, the third root cancel out with the cube. So this is this third root here, cancel out with the cube. Okay, so now it's just x. This is equal to x. Again, guys, think of the third root like that's like power 1/3. So when you do third root of x cubed, it's like you have to multiply the powers. So it's like 3 times 1/3, and 3 times 1/3, it's like, it's 1, right? So this is like x power 1, right? So it's just x. So we got x in this step, which is good news. So then you can move to the, so there's a hope that g is the inverse of f. So we need to do now, we need to check the step number 2. So step number 2. So now we need to evaluate g of f of x. So it's g of f of x. My g of x, sorry, my g of x is it's x cubed plus 4. So this is x cubed plus 4. And there is an x in here. So this is going to be, so I substitute x by f. So this is my f of x. Now cube, and then plus 4. Right? So that would be equal to f. So my f is third root of, you know, x minus 4. That's my f, right? That's my f. And then there's a cube. So here's my cube, and then there's plus 4, right? So here's the cube, and then there's a plus 4 here, right? Now, again, this, you know, third root cancel out with the cube. So this, you know, this, the third root, sorry. So this third root here cancel out with this cube. Okay, so it's now that's g composed with f of x. It's just x minus 4. And then there is a plus 4 here, right? So this is plus 4 here. Okay, and then of course, here's minus 4 plus 4, cancel out, so that will be just x. And again, we got x, right? Just x by itself. So in both steps, step 1 and step 2, we get x as answer. And so conclusion is that this g is actually the inverse of f. So here's final answer. So conclusion, g is f inverse. Okay, or g is the inverse of f if you prefer. The inverse of f. Any question about this number 2? Okay, just be careful with the exponents. All right. Okay, last one. I think it's okay. Number 3. So this is 4 over x plus 9 and 4 over x minus 7. Okay, perfect. So let's do number 3. All right. So here's number 3. Okay, so as usual, step 1 here. So it's f composed with g again. It's f of g of x, f of x. We said I think it's 4 over x plus 9. So here's my x. It's in the denominator, right? So we're gonna have 4 over g. So here's my g of x, and then there is plus 9. This is plus 9 here. All right. Okay. So so let's do it. So this is f composed of the g of x. It's 4 over g. So what's g? G is 4. You know, let me write it in blue. 4 over x minus 7, right? And then of course there's plus 9. Okay. Now guys, just be careful. So here you see in the top I have 4, and in the denominator I have this 4 over x minus 7. Again, my advice, whenever you have like a division of fraction, like a whole number over a fraction like here, my advice is just to divide the whole number by 1. So this, like, let's say this 4 over 1. All right. So now I have a fraction in the top, I have a fraction in the bottom. And so how do we divide fractions? Well, you flip the fraction in the denominator, right? So all I have to do now is to flip. So this is f composed with g of x. So we're gonna have 4 over 1. That's my fraction in the top, right? Times, and then I'm gonna flip this one here, the denominator, right? So that's times. x minus 7 over 4. All right, and then plus 9. Okay, and so then of course, this is multiplication of fractions. You multiply straight across. So this is f composed with the g of x. So it's 4 times the x minus 7. Don't forget the parentheses, right? It's 4 times the whole thing. So it's going to be the x minus 7 between parentheses. And in the bottom, we have 1 times 4. So it's 4. There's a plus 9 here. And then here we have 4 in the top, 4 in the bottom, so they cancel out. So this 4 here goes away. All right. Again, I can cancel out the 4 because I have a multiplication, right? So you need a multiplication in the top and in the bottom to cancel out, right? So this cancel out, 4 cancel out, and then it's just x minus 7 now. So this f composed with g of x, now it's x minus 7. When you cancel out the 4 in the bottom, this is like 4 times 1. So actually, you're left with 1 in the bottom. So this is like x minus 7 over 1. And I mean, any number over 1 would be the same number. So x minus 7 over 1 is x minus 7. All right, and then this is plus 9 here. Now, minus 7 plus 9, that would be plus 2, right? So this is so f composed with g of x, it's x plus 2. Yes, yes, absolutely, Mamadou. So it's x plus 2. And yeah, so you're done with the simplification, right? Nothing else you can do here. It's just x plus 2, and which is not x. Obviously, this is not x by itself. This is plus 2, right? So it's not x, so it's not equal to x, right? Not equal, right? Because of the plus 2. And so then, so you can just stop here. You don't need to do the step number 2. So you can stop here and say, so find the answer, G is not the inverse. G of x is not the inverse of f of x. So it's not the inverse. Right? Any question, guys? No questions? Okay, perfect. Okay.
Wait,
Actually,
Professor, can you
yes.
also write it, Professor, can you also write it as, I don't know how to say this.
Right, what?
So you see how you put g of x and you put equal, and then you put f exponent -1. So you could put not equal in the middle instead of writing the whole thing.
Yeah. You can do that. Yeah. So we are saying here in the conclusion you can write g of x not equal to this f, like, yeah.
Okay.
That's what you mean, right?
Yes, that's what I meant.
Yeah, absolutely. You can do that too. Yeah. Absolutely. Okay, so guys, actually, there's something interesting about these inverse functions. Okay, so let me do an example to see how this inverse function works. So, for example, remember we had this f. So we have this f of x, which is 4x minus 7. This was my first example. F of x is 4x minus 7, and g of x is x plus 7, the whole thing over 4, right? And this was my first example, and actually we checked that g is the inverse of f, right? That's what we did. So we checked. So we already checked that g is the inverse of f. Okay, That was my first example. Anyway, so what's interesting about this this f and g? Well, so if you make a table of values, let's say here, I'm gonna make a table with the values of f. All right, so here's my x, here's my f of x, right? So my f of x, of course, is for x minus 7. All right, so let's say, for example, x is 1. All right, so what will be f of 1? F of 1, you know, it's 4 times 1 minus 7. So 4 minus 7, that would be negative 3, right? Yes, yes, Kwame, absolutely, it's negative 3. Or let's say if my x is 2, then f of 2 would be 4 times 2 minus 7, 8 minus 7, it's 1, right? So I'm gonna have 1 here. Let's just take another example, last one. So for example, x is 0, then f of 0 would be 0 times 4, 0 minus 7, so it's gonna be negative 7, all right? Now, so what's interesting about the inverse, so this, again, this g here is supposed to be the inverse, right? This is the inverse. So what I'm gonna do, I'm gonna interchange the values of the y and x. So let's say this is now g of x. So let's say, for example, x is negative 3. Okay, so what will be g of negative 3? All right, so you know, g is x plus 7 over 4, right? So it's like, so it's gonna be like negative 3 plus 7 over 4. So it's going to be 4 over 4, and 4 over 4 is going to be equal to 1, right? So this is actually, this is equal to 1, right? G of negative 3 is equal to 1, right? Because again, if your x here is negative 3 plus 7 is positive 4 over 4 is going to be 1. Or let's say if your x is 1, then what would be g of 1? So here, if this x here is 1, so 1 plus 7 going to be 8. 8 over 4, it's 2. So g of 1 is 2. Okay? And if you, for example, your x is negative 7, then g of negative 7, it's if your x here is negative 7 plus 7, that will be 0, and 0 over 4, 0 over any non-zero number is 0. So then g of negative 7 would be 0, right? So the thing, guys, I mean, if you see here, so it's like you interchange the values of the input and the output. So you see here, so if my x is 1, my f of 1 is negative 3. Now, if my x is negative 3, right, then g of negative 3 is 1, right? So it's like it's like you interchange the x and the input x with the output y, right? Here the same. So you see here, if your x is 2, then f of 2 is 1. Now for g, for the inverse, if your x is 1, then the g of 1 would be 2. Okay. As you're saying, Glenn, you're saying, can it be a graph? Yes, it can be a graph, sure. Yeah, so that's what I'm gonna do, like in a minute. Yes, but so the idea here. So what I'm saying here is that okay. So the idea is the following. So if, let's say, if f of 1 is negative 3, then f inverse of negative 3 is positive 1, right? F inverse, which is g, right? F inverse is supposed to be g, right? This is my f inverse, it's g. So you see f inverse of negative 1 would negative 3 would be positive 1. Or if you see if f of f of 2, we said it's equal to 1, right? Then f inverse of positive 1 would be equal to 2, right? So you see, you just interchange your input with your output, right? You see here, you interchange your input with your output, right? So that's very, I mean, that's very interesting, right? It's and actually we're going to use this observation to find, so we're going to use this. So we're going to use this observation to find the inverse of a function f, to find the inverse. So again, guys, the idea is if like f of 4 is 5, then f inverse of 5 would be 4. Or if f of 0 is 100, then f inverse of 100 is 0, right? So you see, you interchange the x and the input with the output, right? So yeah, so now the question is, how do we find the inverse? How do we use this observation here to find the inverse? Well, so the question now, so how do we find the inverse? Find the inverse. Okay. Oops. The inverse. So what I'm gonna do, guys, I'm gonna have like a table with 2 columns. Here, let's say. So in the left column, I'm gonna have my example, right? And on the right, I'm gonna have the steps, right? So for example, again, so the goal here is to find the inverse. So the question was, how do we find the inverse? So let's say, let's pick a random function f. So let's say f of x is, 4x plus 7, all right? And I want to find the inverse. Okay. So first step, step 1, what I'm going to just do in the first step is to just replace, so step 1, just replace f of x by y. Okay, replace f of x by y. All right. So what I'm saying here, like here in this example, this f of x is gonna be now y equal to 4x plus 7. All right. That's the first step. Just replace f of x by y. Now I'm gonna use my observation. Right, so we said we have to interchange x and y. So now I'm gonna, in the step 2, I'm gonna interchange. So I'm gonna interchange x and y. So what do I mean by interchange x and y? So y becomes x. So this y here becomes x, and my x here becomes y, right? And still we have here an equation, here 4, and here plus 7. All right, you just interchange x and y, okay? And then in the last step, I'm gonna solve for y. In step 3, solve for y. All right. So like here, if you want to solve for y, you can subtract 7 both sides. right? So subtract 7. So that's like x minus 7 equal to 4y, right? And then we can divide by, you need to get rid of the 4, right? You want to solve, again, you want to solve for y, right? So I'm going to divide by 4, both sides. And so my y, so that's x minus 7 over y equal to y, right? This 4 here, cancel out, right? So once you solve for y, so then that will be your inverse function. So this is, so that's the answer. I mean, so the inverse, so then the inverse function, right? So f inverse is equal to x minus 7 over 4. Right? So that's the inverse of this function here. So we started with f of x equal to 4x plus 7, right? That's my initial function f, right? And so the inverse is actually this function here, this one, x minus 7 over 4. Okay, so that's how we find the inverse. You have basically, all you have to do is to interchange your input with your output and then solve for y. Well, the problem with these steps is that, you know, sometimes you cannot solve for y, right? So you cannot always solve for y. So that's the main issue here. The problem is that, well, first, is there any question about the steps here, how I got this f inverse? Okay, so I was saying is that we cannot always solve for y. So there's a problem with the step number 3. So so this is remark. Oops. So we cannot always solve for y. Okay. Well, so let me give you an example where you cannot solve for y. Okay, very basic, very simple, a very simple example. All right. So I'm gonna try to follow the same steps. So here's my example. So let's say my f of x is equal to just 2. All right. I mean, here the function f here, it's just, you know, the output is always 2. All right. For any input x, the output is 2. So this is a constant. That's what we call a constant function, right? This is a constant function because the output is always the same. It's always 2, right? The output y is always 2, right? So this is a constant function. So I'm gonna try to follow the same steps. You know, you wanna find the inverse. Let's see how it works. So, you know, step 1, we said, step 1, replace or substitute f of x by y. Okay, so that's not a problem. Here's my f of x. Now it becomes y, so y is equal to 2, right? Now interchange in the step 2, interchange x and y. Right, x and y. So when you say interchange x and y, it means the y becomes x. So this y here becomes x, and then your x becomes y. But there's no x here, right? There's no x. So here there's no x, right? There's no x. Okay, so I'm gonna have just x equals x equal to 2, right? Because again, because there's no x. So I have this x is equal to 2. Now step 3, and the step 3, I'm supposed to solve for y. But that's not possible because, I mean, there's no y, right? So this is not, so it's not possible. I mean, here x is equal to 2. Well, it's not possible to solve for y because there is no y, for the simple reason there is no y, right, to solve for y. Well, because there is no y. There is no y. Okay. So you see, this is an example where you cannot really solve for y. Okay. Another example is sometimes your y is not a function. So yeah, well, so this f of x equal to 2 has no inverse, right? This f of x is equal to 2 do not have an inverse. An inverse, right? Because we cannot solve for y. So another example where actually you can solve for y, but y it's not won't be a function. So this is another remark. So sometimes y is not a function. Sometimes y is not a function. And so, for example, so here's an example. So I'm gonna again follow the same steps. So here's my f of x, and let's say f of x is equal to x squared. Right? So we said first replace f of x by y. F of x by y. Right? So this is now y is equal to x squared. Right? Then next, interchange x and y. Interchange x and y. All right, so this y here becomes x equal to an x here becomes y, so that's x equal to y squared, right? And then we said we have to solve for y. Solve for y. So then your y, you apply a square root, right? But just be careful because this is an even power. This is even. All right, then you're gonna have plus or minus because it's even, right? So plus or minus square root of x. All right. But then y, remember guys, y equal to plus or minus square root of x is not a function, right? Y. So y equal to plus or minus square root of x is, it's not a function, right? Because remember we said in order to be a function, for each input x, there is exactly one output, right? But here for an input x, for example, if x is 1, you're gonna have two possible outputs, right? So because because of the definition of a function, right? Because we have two possible outputs. So y is not a function of x, because we have two possible, because of the plus or minus, right? Two possible outputs. All right. And so y is not a function. So then, this function f x squared doesn't have an inverse. So then f of x x squared, this function here do not have an inverse. All right, so you see guys, so if you follow these steps, sometimes you cannot solve for y. Sometimes y is not a function of x, right? So then your function do not have an inverse. So anyway, so the idea is that not all the functions have an inverse, right? Some functions have an inverse, some functions they don't. Okay, so it's just because of this last step when you have to solve for y, sometimes it doesn't work. All right. Is there any question, guys, about these steps, about these examples?
Oh yeah, I do.
Yes.
So that means that we can use two different methods. That's
No, it's the same method
it's the
here.
same. Oh, okay.
No, it's the same. So the steps are the same here, right? You see here, you replace f of x by y, you have to change x and y, and then you solve for y. All right, but all I'm saying is that in the last step, sometimes your y, you cannot solve for y. So if you cannot solve for y, then you don't have an inverse. Or if your y is not a function, then you don't have an inverse, right? But the method is the same, right? It's the same steps.
Oh, okay, got it.
Any other question, guys? Okay, so I'm gonna give you a couple of functions, and then you need to follow these steps and try to find the inverse. Okay, so the question now is to find the inverse. Okay, so exercise. So please find, if it's possible, of course, find the inverse, if possible, the inverse of f of x. All right, so so let's say f of x is 3x plus 4. F of x is 4 over x plus 1. And then f of x is, say, 5 minus x over 1 plus x. Okay. Yes, I can. Yeah, Lenin, I can go to the previous example. Yeah, sorry. Yeah, so guys, you have 10 minutes to think about, this exercise. And again, all you have to do is, follow these steps here. You see the steps right here. You replace f of x by y, interchange x and y, and then solve for y, right? So here's an example where it works. Here. Okay, so probably I should move the board down here. Here's again the exercise. Okay, example 2. Yes. Okay, example 2. Example 2. So this was the example 3. This one, Lenin, with the f of x is equal to 2. Example 2. Nope. Okay. Okay. I see it. Oh yeah, this one. Probably you mean this one. Let me check. So you're saying, is that 4x minus 4 over 3? X minus 4 over 3. X minus 4 over 3. X minus 4 over 3. Well, I hope it's this one here. Up. Okay. Go up. 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 Okay. Where's the? I'm not sure which example. Is still up or? There. Okay. Oh, you mean the cube? Oh, okay, okay, okay. I guess this one here. Yeah. I mean,
Professor,
anyway, yes, yes.
sorry.
No,
No, I was
go
gonna
ahead.
say I handed in my
Mm-hmm. Homework?
Yeah, for number 3, but you said that you graded number 3, but I didn't get graded for number 3.
Yeah, did you upload it on Blackboard?
Yeah, I uploaded it 2 days ago.
When?
2 days ago.
2 days ago.
Today.
And you're saying you didn't get your grade.
Yeah, because you were saying that you graded number 3, but I didn't get graded for mine.
Oh, okay, okay. Okay. What's her name?
Roberts, Leah.
Oh,
Leah
Leah. Okay, Leah. That's weird. Okay, I will check it, Leah. I will
Okay.
see. No, don't worry. I mean, I will check it.
Okay.
That's weird. Yeah. Okay. Yeah, I think Mamadou, I got the same problem again with your file. I mean, I cannot open your file.
Yeah, but I sent emails and you send me the grades.
Oh, okay.
Yeah.
Okay. Okay, let me check the okay. Okay, great. Yeah. Okay. Homework 3. I mean, Leah, I see you got 10 over 10 in the homework 3.
Let me check.
Yeah, I see your grade here. I mean, it's on Blackboard. So you are talking about homework number 3, not 4, right? I mean, I didn't grade yet the homework 4. So yeah, I see your grade here.
Oh wait, 4 is the one that had what we
No, the
covered
4.
on class on Monday.
Yeah, I mean 4 is due
Oh,
today.
okay. I confused
Yeah,
4
yeah.
and 3. Okay.
Yeah, 4 is due today. I mean, of course, I didn't grade the 4 yet. Yeah.
Okay, I was confused then.
No
Okay.
problem. No problem. No, I mean, I mean, sometimes, sometimes I forget to grade the homework or something. I mean, it could happen. I mean, it's not. Yeah, Lenin. I mean, anyway, I will upload the notes on Blackboard as usual. I mean, even if you you missed the last part, I mean, you can find it later on Blackboard. Mm-hmm.
Sir,
Yes,
the
I can.
inverse of f of x, can you get two values?
No, you cannot get to values.
Okay.
What do you mean? Like a solution?
Yeah.
No, you
No.
cannot get to different values. No. Yeah, so be careful with number. I mean, number 2 and especially, I guess I would say, especially number 3. I mean, it's not. I would say it's not obvious actually how to solve for y. Okay, so yeah, so number 1, your answer again. The steps, guys. I mean, if you missed any part of the lecture, but the steps you need to know are they are here again. So you need to. So you see here. So this is like a first step, replace f by y, interchange x and y, and then you solve for y. Okay, so those are the steps. And so yeah, so what I'm saying is probably number 3 is kind of tricky. You need to think a little bit about it. How to solve for y. So yeah, again, just to remind you guys, so next Monday, it's a Columbus Day, it's a holiday, so we don't have a class next Monday. We're gonna meet as usual on Wednesday. And I'm gonna post the review sheet for the test next week, all right? And so, I mean, we are almost done with this section. This is the last section of chapter 1. So we are almost done with the chapter 1. So for sure, I mean, chapter 1 is gonna be in the test. Now the question is, well, it depends on next week, but I'm gonna probably include one section from the chapter 2, the first section from chapter 2. Okay, but again, it depends on next week. I will let you know anyway next week what will be exactly the material for the test. But for sure, the whole chapter 1 is gonna be in the test for sure. And anyways, I mean the problems in the review sheet, they're gonna be kind of similar to the problems in the test. So I mean there will be no surprise. Okay, so it's not there will be no surprise. So don't worry too much about the test. Well, of course you have to practice. That for sure you have to practice. Go over your homeworks. And yeah, and then I guess you're good.
So, Professor, as an answer, we're supposed to say, this is an inverse function after we find the, after we solve for y.
Yeah, yeah, yeah. Yeah, like where is it? Yeah, like here. You see, I want, once you solve for y, then you have to write like the inverse function f inverse is you know, blah blah blah.
Okay.
So any guess for number 2? Did anyone find the inverse for number 2?
I just have a question about number 2.
Yeah.
Because I'm up to the part where it's x minus 1 equals 4 over y.
Yeah.
I don't know what to do next.
Yeah, so the idea is to, so we want to move the y to the top, right? But so what we can do is we can flip the both fractions. You know, it's like, so I guess you have like, you know, you have like, sorry. Yeah, so you have like, you know, 4 over y, and then you have like x plus 1, right? Or, I mean, something like this, right? So what you can do is, you know, this x plus 1, you make it as a fraction, so you divide by 1, and then you can flip both fractions. So it's going to be like y over 4, and then like 1 over x plus 1. Okay, so if you flip both the fractions, then it's going to be still equal.
I think I'm gonna just wait till you do it.
Okay, okay. You know, it's like when you have like let's say you have like a 2/4. I mean, 2 over 4 equal to half, right? Right. Then if you flip both fractions, so it's gonna be 4 over 2 is equal to 2 over 1, right? That's 2 is equal to 2, of course, right? So I mean, if you have like you know, an equation with the fractions, then you can always like flip both fractions, and it's going to be still equal.
Okay.
Okay, guys. Probably we don't have. I mean, we have like 3 minutes. So I'm gonna start with number 2. Okay. And I mean, if I don't finish today, I will finish this exercise next time. Okay. But let me do number 2, because I guess number 1 is kind of similar to the example we had, so it's not that hard. But let me start with number 2. And again, if I don't finish the exercise today, then I will finish it next time. All right. So so let me solve number 2. Here, so this is number 2. So first, we have f of x, 4 over x plus 1. So we said first thing, just replace this f of x by y. So here's my y. And then this is 4 over x plus 1, right? And then we said y, interchange x and y. So y becomes x. So this y here, oops. So this y here becomes x. So that's equal to 4 over, and this x here becomes y. And then we're gonna have plus 1, right? Now we have to solve for y, right? So, so what we can do is, when I solve for y, you can subtract 1 here, subtract 1 here. So we're gonna have x minus 1 equal to 4 over y, right? So, I mean, as Leah was saying, the problem here is that your y is in the denominator, right? You wanna move your y to the top, okay? So if you wanna move the y to the top, what you can do is you can flip the fraction on the right side, okay? So if you flip the fraction on the right side, that will be y over 4. But the thing is, if you have an equation and you decide to flip the right side, then you have to flip the left side, all right? Because it's an equation, right? So whatever you do to the right side, you have to do the same thing to the left side. Now, the left side, it's not, it looks like it's not a fraction, but again, you can make it look like a fraction. So just by dividing by 1, right? You divide here by 1, so now it's a fraction, right? So as I said, the problem is you want to move y to the top, and the way to do it is to flip, right? So I'm gonna flip both fractions. So this is gonna flip it, and again, whatever you do to the right side, you do the same to the left side. So if you flip the right side, you flip the left side, right? So now it's 1 over x minus 1. And this is y over 4. All right, makes sense? Again, if you have an equation with the two fractions, fraction on the left side, a fraction on the right side, you are allowed to flip both fractions, okay? It's still equal, okay? Now, why this is good? Because now you have your y in the top, this is good. So all you have to do now is to get rid of the 4, right? This is over 4. So all you have to do now to get rid of this over 4 here, you have to multiply by 4. So I'm going to do the same here. I'm going to multiply by 4. Once you multiply by 4, so you're going to have 4 in the top and 4 in the denominator, so they cancel out, right? So this is 4 times 1 over x minus 1. And again, this 4, this is like 4 over 1, right? So it's like 4 times 1, it's 4, over 1 times x minus 1, it's x minus 1, right? And the right side here, it's just y, right? So you see how I got the y here? And so the answer, of course, conclusion, that's my function, the inverse, right? So conclusion, f inverse is this 4 over x minus 1, right? Okay, so yeah, anyway, so this is how we solve number 2. Sorry, of course, I'm over time. So I'm gonna finish this exercise next time. We are almost done with this section and this chapter 1, and then probably gonna start chapter 2. Well, thank you guys. So I'm gonna stop here. I will see you next Wednesday. Please don't forget your homework number 4. It's due today, and I will post homework number 5 tomorrow, okay? Thank you, everyone, and take care and stay safe.
Professor, homework number
Yes.
1 isn't on Blackboard for me. Remember, I sent it to you on email, and you graded me through email. Are you going to post it on Blackboard?
Yes.
All right.
Homework number 1. Let me see. Oh, did I send you an email, right, for homework number 1?
Yeah, you did. That's why I got
Okay.
confused because I didn't see homework number 1 posted on the grades.
Oh, no, but don't worry, because I have my grades on a different file, so it's not on the
Okay.
Blackboard. Yeah. No, you're good. You're good.
All right.
Sure. Thank you, everyone.
Bye.
Bye. See you next time. If you have any question, I'm here.
Yeah,
for
yeah,
a minute or
for
two. Yes.
yeah, for me to you graded me the homework number 2 and 3. You sent me the answer, but on Blackboard I got 0.
No, don't worry, Mamadou. It's that's because it's just because I couldn't open the file. But of course, I got your grades on. It's the grades are in the separate file. It's not on the Blackboard, so that's where I keep them grades. Yeah, no, you're good. You're good. Don't worry.
Oh, okay, thank you.
Sure. Thank you, guys.
Thank you, Professor. See you next
Thank you, guys. Take care and stay safe. All right.